Okay, so let's start. After the class, I will share the link in the group so you can watch on the YouTube also. Okay. So the topic we are starting today is properties of ethanoic acid. Properties of ethanoic acid. Okay. So what is the formula for ethanoic acid? It is CH3. Just a moment, please. So it is CH3COOH. CH3COOH. Okay. And ethanoic acid is called carboxylic acid. It has COOH group. Okay. It has COOH group. 5 to 8% solution of acetic acid is called vinegar, and you might have seen vinegar is used in the pickles as a preservative. Okay, it is used as a preservative, so it prevent spoiling of the pickles. Okay, or you might have seen in the restaurant they keep onions, they keep onion in the acetic acid solution. Okay, so the onion looks pink. So that, yeah, it is an antioxidant, so it can prevent spoilage for longer duration than usual. Okay, so it will last little longer. Okay, so CH3 CH3 COOH is the formula for ethanoic acid. So there are two carbon, so ethane, and they have COOH, so ethanoic acid. Okay. 5 to 8% solution of acetic acid in water is what? Vinegar. Vinegar. And vinegar, as I already told you, it is used as preservative in pickles. Melting point of pure ethanoic acid, it is 290 Kelvin. So it will freeze during winter in cold climate. In cold climate. Okay. So because of it, it is called glacial acetic acid, because it will freeze and form ice. So it is called glacial acetic acid. Okay. So these group of compound are called carboxylic acid, and that is why these are acidic in nature. Okay. But the other acid, for example, HCl or H2SO4, etc., these are called mineral acid. These are called mineral acid. And the acid that we are talking about right now, or we can take other such acids, for example, CH3, CH2, COOH. It is propanoic acid. So these acids are weak acids, while mineral acids are strong acid. So if you perform this activity, you will see that the mineral acid will produce more changes in the litmus paper as compared to weak acid like ethanoic acid. Okay. Okay, so what is the reason? Because these strong acids are completely ionized. Strong acids are completely ionized. What is the meaning of completely ionized is, for example, if we have 100 molecules of HCl, okay, so all 100 molecule of HCl will be broken and they will produce 100 proton plus 100 chloride ion. Okay, but in case of weak acid, this number will be very less. For example, out of 100 molecule of ethanoic acid, let's say some 30 are broken or 20 are broken. So in that case, we will just has 30 H plus ion and 30 CH3 COH ion, and remaining molecule will be there as such. Okay, remaining molecule will be as such. Understood? Understood? Clear? Okay. So unlike mineral acid, for example HCl, which are completely ionized, carboxylic acid are weak acid because they are not ionized completely. Okay, done. Then we will talk about reactions of ethanoic acid. So one very important category of reaction of ethanoic acid is esterification. So what is the meaning of esterification? Means uh, formation of ester. Formation of ester. And what is the symbol of ester? So it is RCOOR. It is RCOOR. It is called ester. So like other compound, aldehyde, ketones. This is another category of compound called ester. Okay, and the process of making an ester is called esterification. This process is called esterification. Okay, so how this reaction is happening? This is CH3COOH. Which acid it is? Which acid it is? Somebody is again asking what is the meaning of R. So I have told you a million times that R is alkyl group. So whenever you remove, for example, you have a methane, whenever you will remove a hydrogen, you will get methyl with one free bond. Okay, so this is your alkyl group. It is written as R. Okay, and this is variable, means the number of carbon atom in the R could change. It might be 2, 3, 4, 5, any number. Okay, so it is a variable group. Done? Done? So we were seeing this reaction RCOOH. In this case, it is ethanoic acid. It is reacting with ethanol, that is CH3CH2OH, that is an alcohol. So an acid is reacting with alcohol and it is forming an ester. It is forming an ester. Okay. So this is the wrong. This is the wrong formula of ester in the NCERT. See, this is a ketone because C double bond O. This is a ketone. Okay. So let me tell you how it is formed. So what you have to do is you simply write these two formula close. So I am writing here. So CH3 COOH, and second formula is CH3 CH2 OH. Okay, So what you have to do is, this is an acid, it will release H plus ion and take OH from here. Okay, so this is the H2O, and the resultant what is left is your ester. So we can write it CH3, C double bond O, then O, CH2, CH3. This is the correct formula. Okay, please note it down. This is the correct formula for ester. Okay. So it is understood, or should I explain once again? It is understood, or should I explain once again? Clear, everyone? Okay, I'm explaining once again. So let me clear this area if you have already written. Done. Okay, so I'm writing this equation that they have written there. CH3 COOH plus CH3 CH2, sorry, yes, OH, CH3 CH2OH. So H and OH is going out as water. So I'm writing here H2O, and the product is CH3 C double bond O, and here single bond O. I have to displace it a bit. Okay. Then the remaining part, this one, CH2 CH3. Okay. So this is how you have to write the product. Now is it clear, everyone? So this is an ester. This is an ester. Okay, good. So what are the properties of ester? So esters are generally sweet smelling substance. These are generally sweet smelling substance. Okay. These are sweet smelling substances. These are useful in making perfume and flavoring agent. Perfume and flavoring agent. Okay. So if we are treating them, no, ester is not used in cooking. It is not used in cooking. Okay. On treating with sodium hydroxide, sodium hydroxide is a base or alkali. Ester is converted back to alcohol and sodium salt of carboxylic acid. And sodium salt of carboxylic acid is called soap. It is called soap. Sodium salt of carboxylic acid is called soap. That means in this process, soap is formed. So that's why this is called saponification. This is called saponification because soap is being formed. So this process is used for preparation of soap. So if somebody asks you what is the definition of soap, so soap are sodium and potassium salt of long chain carboxylic acid. So these are sodium or potassium salt of long chain carboxylic acid. Understood? Understood? Done? Okay. So for example, this is a ester CS3COO C2H5. This is the same ester that we have written here. We can also write it in this way: CS3COO, and this part is C2H5. So we can also write it in this way. Okay. So this is the same ester here, and we are treating it with sodium hydroxide. Okay, we are treating it with sodium hydroxide. So what we will get, how it will be formed. So I am writing at the left hand side CH3 COO C2H5. Okay, and the second reactant we have is NaOH. NaOH. So first you try to identify that how this compound was formed. So how this compound was formed? You have ethanoic acid and ethyl alcohol. So this is the acid part, this one. This one is the acid part, and this one is the alcohol part. Okay, this is the alcohol part. So what we are going to do is this will be broken from here, and it will form CH3COONA, and the remaining part will be C2H5OH. So is it clear, everyone? Is it clear? Is it clear? Okay. Somebody is saying no, sir. So let me explain once again. Let me explain once again. Okay. See, I have picked this compound. Sorry. I have picked this compound and I have written it here. Okay. So what compound it is? It is a ester. It is a ester. Okay. So we have to cut this ester in two parts. So I am cutting this from here, and another reactant we are using in this reaction is this NaOH. So I have cut NaOH also in two parts. Okay, so it is Na plus and OH minus. Na plus and OH minus. Okay. And another point, let me tell you, if I am writing CS3COOH, this is a acid. This is a acid. And if I dissolve it in water, it will lose H plus ion, right? So remaining part will be CH3COO minus. Okay. So in this compound CH3 COO C2H5, can I assume that C2H5 is in place of H? C2H5 is there in place of H. Understood? Understood? Okay, so what I am doing is I am removing C2H5 from there, similar to H plus. So the remaining part is CH3COONA minus. Okay, and when we are breaking this NaOH, so it is producing Na plus and OH minus. Okay, Na plus and OH minus. So C2H5 is combining with OH, producing C2H5OH, and Na is combining with CH3COONA. So CH3COONA. Now clear or not? Clear? Everyone? Is it clear or not? Okay, good. So now you can easily write the product, right? Now you can easily write the product. So should I clear it? Should I remove it from the board? Okay. The next question is reaction with base. Reaction with base. So ethanoic acid react with base such as sodium hydroxide and it will form a salt. So this reaction is again easy. This reaction is again easy. Just a moment please, okay? Okay, so reaction with base. So like mineral acid, ethanoic acid react with a base, for example, sodium hydroxide, and they will give a salt. So how to write this reaction? This is again very easy reaction. So I am writing it like this. NaOH plus HOOC CH3. Okay, why I am writing it like this? It will be easier. Okay, so what I am doing, OH from here and H from here. So it will be removed as water and the remaining I can write as a product. So product will be CH3COONA plus water. Clear? Any doubt in this equation? Any doubt? No. Okay. In the same way, other equation we can write a reaction with carbonate and hydrogen carbonate. Reaction with carbonate and hydrogen carbonate. So what is carbonate? Carbonate is Na2CO3. And what is hydrogen carbonate? It will have HCO3. So these are sodium carbonate and sodium hydrogen carbonate. Sodium carbonate and sodium hydrogen carbonate. Okay. So what we are going to do is we will write CH3 COOH. Okay, and since we are using sodium twice, so we have to write it twice, and it is Na2CO3. Na2CO3. Okay, so how we are going to write the product? It is very simple. Again, you have to cut it from here. So what you will get? You will get CH3COONA. Okay, so you are combining this part and this part, so you will get 2 CH3 COONA, 2 CH3 COONA, and now you have CO3 and H. Again, how many hydrogen you have? Because you have 2 here, so you have 2 hydrogens. So you are left with 2 hydrogen and 3 oxygen and 1 carbon. These 3 oxygen and 1 carbon. Okay, so you will take 2 oxygen and 1 carbon to write CO2. Then you will be left with 1 oxygen. So 1 oxygen will combine with these 2H and it will form water. Is it easy? Okay. Is it clear, everyone? Yes. And same thing you have to do with next reaction. So next reaction I am writing on the right side. So we have CS3 COOH and plus NaHCO3. Okay. So now we have taken just one molecule. This will be broken from here and this from here. So the product we are going to have is CS3COONA plus again 2 hydrogen, 1 oxygen will form water and the remaining part will be CO2. Clear? So I think you will not face any difficulty in writing the product of these reactions. Okay? Done? Are you still writing? Okay, let's do those two questions. You have to do first one. How would you distinguish experimentally between alcohol and carboxylic acid? What is the answer? What is the answer? Okay, Rajeshri, good, good. Yes, I have told that we will revise the all chapters at once. But problem is your exam has been cancelled. Do you know this? The exam got cancelled. Somebody told me I have to confirm this news. Okay. Okay, okay. Okay, if it is not cancelled, then yeah, in Tamil Nadu they have cancelled. Yes, I will check and confirm the news. Okay, somebody told me in the morning. I will tell tomorrow. Let me confirm the news. Okay, let me confirm the news. Okay, so what is the answer for the first question? What is the answer for first question? Okay, wait, let me check. Wait, I'm checking. There's one news. There's one news from NDTV, and they are saying Karnataka SLC exam on schedule, and school will reopen after August. Okay. So that means they are not cancelling the exam. Yeah, this news was updated 12 hour ago, and it is from NDTV. It is from NDTV. Okay. And the same news is in Hindustan Times also, but there is one Hindi newspaper which is saying no SLC in Karnataka 2020. So, but most of the places they have given that they are conducting the exam. In the most of newspaper they have given they are conducting the exam, except for one or two. Okay. On schedule means it will be conducted. On schedule means it will be conducted. Okay. Okay, so let's solve this question. How, and this was one of the student who informed me in the morning. One of the student who is in the class, this he was saying that exam is cancelled. So I'm not getting his name now. Let me go back. Yeah, it was Soumya. Soumya, tell me from where you got this news. Reply in the group, Soumya. Okay, Soumya is saying she saw in the TV. Okay, okay. Okay, so let's continue the question. We are solving this question number 1. How would you distinguish experimentally between an alcohol and carboxylic acid? Okay, so the first test is uh, reaction with a base. Reaction with base. So, for example, we are taking CH3, COOH, and NaOH. Okay, what will be the product? What will be the product? Yes, Rahul, yes. What will be the product? We have done this equation like a few minutes ago. Break it from here. Break it from here. CS3 COONA plus H2O. This will be the product. Okay. And if we conduct the same reaction with the alcohol, for example, I am taking C2H5OH and making it react with NaOH. So it will give no reaction. It will give no reaction. Okay. Done. Second test is reaction with sodium bicarbonate. Reaction with sodium bicarbonate that we have also seen earlier. So CH3COOH plus NaHCO3. What will be the product? What will be the product? We have seen it earlier. Tell me the product. Yes, it is CS3 COONA plus H2O plus CO2. This is the product. Okay. And same reaction we conduct with alcohol C2H5OH plus NaHCO3. So there will be no reaction. There will be no reaction. Understood? So this is how we can distinguish the two. Okay. Okay. Next question. What are oxidizing agent? What are oxidizing agent? What are oxidizing agent? Okay, so these are the substance which can add oxygen to other substances. These are the substances which can add oxygen to other substances. For example, KMNO4 or K2Cr2O7. Okay, KMNO4, it is called potassium permanganate. And this one, KMNO4, and K2Cr2O7, it is called potassium dichromate. Okay, so these are the oxidizing agent. Done. Yes, it will get correct. I have just changed the screen, that's why. Okay. The next topic that we are going to cover is soaps and detergent. Next topic that we are going to cover is soaps and detergent. So in this diagram, I'm going to show you how a soap works. Okay. So this particular part you are seeing with head and tail, this is a soap molecule. This is a soap molecule. And the yellow part in the center, it is a oil droplet. Okay. So for example, if this is your cloth, the piece of cloth, and an oil droplet is sitting on the top of it, this is a oil droplet. Okay. So what will happen? These soap molecule will come. Soap molecule has two parts. The tail is hydrophobic and head part is hydrophilic. This is a hydrophilic part. Okay. So many soap molecule will come and they will hold this oil droplet with their tails. Okay. And since this head since this head is ionic part, so it can easily dissolve in water. Okay. So water molecule will come from this direction and along with soap molecule, they will take away the oil. Okay. And your cloth will become clean. Your cloth will become clean. So is it clear, everyone? Is it clear? Okay. So soap has two parts. One is hydrophilic part and one is hydrophobic part. And the oil droplets are hydrophobic in nature. So hydrophobic part of the soap and the oil droplet will combine together. Since head part of the soap is water soluble, it will dissolve in water and it will take away the oil along with the soap molecule. Okay. Okay, somebody is asking what is hydrophilic and hydrophobic. Hydro means water. Hydro means water, and hydrophilic means water loving. Okay, water loving means these are the substances that can dissolve in water. These substances can dissolve in water. The hydrophobic part, it is water hating. Water hating substances. Okay, that means do not, they do not dissolve in water. Okay, so I can say there is communication gap between the water molecule and soap molecule. They cannot understand each other's language. Okay, between water molecule and oil droplet there is communication gap. They cannot understand each other's language. So soap molecule will come and soap molecule will ask this dirt molecule or oil molecule that we are going for a ride, you want to come along. So this oil molecule will say yes, yes, I can come. Okay, then water will come and water is friendly with the soap molecule, so water will say, are you coming with me? Soap molecule will say yes, yes, I am coming. So along with soap molecule the oil will also go away. Understood? Clear everyone? Clear? Okay. So let's mark a few lines here. Most dirt is oily in nature and oil does not dissolve in water. Oil does not dissolve in water. The molecule of soap are sodium or potassium salt of long chain carboxylic acid. Okay. So the ionic end of soap interact with water. Ionic end is the head of the soap molecule, and the carbon chain, the tail, carbon chain interact with the oil. Soap molecule thus form a structure and this structure is called micelles. So this particular structure you can see this is called micelles. Okay, so the tails of soap molecules are embedded in the oil or dirt particle. Okay, so the soap molecule thus form a structure called micelles, where one end of the molecule is toward the oil droplet while the other ionic end face outside. Okay, and this will form an emulsion in the water. So what is emulsion? So there are emulsion is a stage between true solution and suspension. Okay, so what is suspension? So you might have seen if you put uh, some soil in the water, the whole water will become cloudy. Okay, whole water will become cloudy. So this is a kind of suspension because all particle will not settle down. Okay, and in case of emulsion, I repeat once again. So emulsion is a stage between suspension and true solution. Okay, in true solutions are homogeneous mixture. Okay, and suspension are heterogeneous, and the emulsion is a phase in between the two. Okay, so these micelles help in pulling out the dirt in water and we can wash the cloth clean. Okay, so this is the same diagram that I have shown there. So you can see this blue part is the oil droplet, and these are the soap particles, soap molecules. Okay, done. Okay, so I'm giving you 2 minute time to revise, then I will ask you a few questions. Okay, so please go through these topics. I'm going to ask you a few questions. So I start asking questions. What is the general formula for alkane? What is the general formula for alkane? Yes, it is CnH2n plus 2. CnH2n plus 2. What is the IUPAC name of the compound that I am going to show you on the board? What is the IUPAC name of this compound? Yes, it is propanol. It is propanol. Okay. My next question is, on burning a hydrocarbon, a sooty flame is formed. On burning hydrocarbon, sooty flame is formed. Then what is the indication? Can you tell about the fuel, the kind of hydrocarbon being used? Yes, it means unsaturated hydrocarbon is being used. It means unsaturated hydrocarbon is being used. Good, good. Why ethanoic acid got its name as glacial acetic acid? Why ethanoic acid got its name as glacial acetic acid? Yes, because its melting point is very low and it will freeze in the colder climate and it will convert in the ice. That's why it is called glacial acetic acid. It will freeze in colder climate. Yes. Okay, next question is, अभी नहीं, 2 मिनट रुको. Next question is, what is the nature of tail in the soap? Is it hydrophobic or hydrophilic? What is the nature of tail of the soap molecule? Answer is tail is hydrophobic. Tail is hydrophobic. Among ionic and covalent compound, which one has low melting and boiling point? Among ionic and covalent compound, which one has low melting and boiling point? What is the meaning of term saponification? What is the meaning of term saponification? What is the meaning of term saponification? It is formation of soap. It is formation of soap. Formation of soap. Okay. How many allotropes of carbon are there? How many allotropes of carbon are there? Can you name? Can you name the allotropes? What are the names of these allotropes? Yes, diamond, graphite, coal, and another one is fullerenes. Buckminster Fuller. Fullerenes. Okay. So that is all for today. Now you can have your breakfast. Thank you. Have a great day.